Okay, let's try our first Lagrange multiplier problem. Okay, we've got a function of two variables, simply x times y. And we've got a constraint, a relationship between x and y. X squared plus 2y squared is equal to 1. Now, it would really be difficult to substitute that constraint into that function. You see, if I rearrange for x by itself, I would have x is equal to plus or minus the square root of some stuff. That's not something that's going to make this function pretty. No, that would be very confusing. Luckily, there is another way. The method of Lagrange multipliers says go up in the number of variables, not down. Don't use the constraint to eliminate one of the variables, but rather add an extra variable lambda, called the Lagrange multiplier. Take the algebraic expression for your function plus lambda times a function here such that that function equal to 0 is equivalent to the constraint equation. Right? So all I've done is taken that equation, I've moved the 1 to the other side, and that is what we use as the constraint function. Multiply it by lambda. Okay, now this is meant to be a function of three variables, x, y, lambda. And the gradient then is the gradient of a function of three variables. It's going to have three components, and all of them need to be 0. That's where the critical points are going to be solutions to this. So let's take a look. Derivative with respect to x. First term gives us a y. The second term we get a lambda and a 2x. Set that to 0. And derivative with respect to y will give us x plus 4y lambda is equal to 0. And the derivative with respect to lambda, as always, gives us the constraint. See how this last line right here, it is equivalent to that. All right. Now, with that, often your goal is, well, a very nice thing to do, I should say, is to just get rid of lambda. Any old way that you can. Because, yes, this system of equations will fix lambda. It will say that lambda needs to be something. But we don't care what it is. Instead, we only care about the x and y components of the critical points. So, what I'm going to do is I'm going to take a look at the first two equations and think about putting the second term from the left side onto the right side and then dividing. So I'd have a y over x, and then I'd have a negative 2x lambda divided by negative 4y lambda, and then the lambdas will go away. I'll have an x over y on the right side with a 2 over 4, which is a 1/2. The negative signs will also cancel. So y over x is 1/2 x over y. Then I'll copy this second equation and more or less copy the other equation too. Now, what I have achieved here is this first line, I could rewrite that as y squared is 1/2 x squared. That is something that I could certainly substitute into the last line very conveniently to get x squared plus 2 times y squared. Well, 2 times 1/2 x squared would be x squared. See, 2 y squared, but y squared is 1/2 x squared. It's equal to 1. Now, this is telling me that x is plus or minus 1 over square root of 2. Right? 2x squared is equal to 1. And then this up here will give me a relationship between x and y. And I'll keep this guy around just to make sure. I mean, it's possible I'll want to figure out what lambda is. I'm not entirely sure yet. So this is minus 4y lambda. Okay, so once again, bringing it all together, not all together, but at least that last equation says that x is 1 over square root of 2, or negative 1 over square root of 2, so I'll put a plus or minus right here. And what does that mean for the other equations? That means that, well, y is plus or minus 1/2, let's see, no matter which of these two things I choose, x squared is 1/2, so 1/2 that is, okay, so 1/2 times 1/2. That means that y squared is 1/4, or y is equal to plus or minus, well, 1/2. Yeah, because y squared is 1/4, so y is plus or minus 1/2. And then I really just do not care about this other equation right here. x is equal to negative 4y lambda, it just doesn't matter to me, right? Let's see, lambda can then take on whatever it needs to in order to make this relationship between x and y be true. So I just don't really care about it. So I should say the solutions now again, when you have a system of 3 equations, you need your solutions to be triples of things, right? And so I should have triples that stand for things I should substitute in for x, y, and lambda. And so what I should do is, set. I suppose in order to be fully honest, I should say x can be 1 over square root of 2, and y can be 1/2. I could also have 1 over square root of 2 with negative 1/2. And, forgot the lambdas. And negative 1 over square root of 2 with positive 1/2. And negative 1 over square root of 2, negative 1/2. Okay, so I completely forgot to do what I meant to do, which was put in a third component here and say comma something or other. Lambda 1, comma lambda 2, comma lambda 3, comma lambda 4, and then say for some lambda 1, lambda 2, lambda 3, lambda 4, all of those guys real numbers, and I don't care what they are. So, now, I have these critical points, and I just do not care about the last components of them. And now let me examine the value of f at these various critical points. Actually, I think I've already completed the instructions. Looking back at the instructions, it says find the points on this solution set to this is an ellipse on which this function has its extreme values. Well, it's going to be at these points, but let's get to work, right? Since f of 1 over square root of 2, comma 1/2 is, let's see, 1 over square root of 2 times 1/2. Let's see, isn't this a 2 over square root of 2? No, square root of 2 over 2 times 1/2, so this is actually square root of 2 over 4, because 1 over square root of 2 is square root of 2 over 2. And f of negative 1 over square root of 2, 1/2, is negative square root of 2 over 4. And isn't that equal to f of 1 over square root of 2, negative 1/2? And then this is the same as f of negative 1 over square root of 2, negative 1/2, which is square root of 2 over 4. Okay. Let's see, I want to find the points on the ellipse. F achieves its maximum, right, subject to the constraint, and the constraint is x squared plus 2y squared is equal to 1 at both the point 1 over square root of 2, 1/2, and at negative 1 over square root of 2, 1/2. and I should say, and it's minimum at, and then I will go on, but we got to stop the video. It's getting a bit